My chemistry minions, what's up?
It is another video with Milks and MoNaCo and moles of stoichiometry.
Yeah.
We're going to count some more atoms. So it's like Sesame Street. You remember the moon monsters?
Yeah.
Yep.
Page 9.
Page 9.
But we're gonna do moles now on top of it. So
within a chemical equation.
Right. So we're going to add on from where we were before.
We were doing compounds. We were counting atoms and compounds. Now we're going to count moles of atoms in chemical equations. Got it. Let's go.
Good. So first things first. The coefficients in front of every compound refers to how many moles of that entire compound.
Yep.
Okay, so this was, unlike the parentheses, for the subscripts were just to the parentheses that it was directly in front of it.
This is like a big old number out in front.
Right.
Got it. And you'll know that it's a different because it's going to be a big old number.
Right.
Out
like
in front.
physically, it's larger.
Yeah, it's the size of the same element as the elements. It's clearly not a subscript.
Right. It's not that little tiny. Right.
All
right. So let's use this equation we have right here as our first equation.
Okay. 2H2 plus 1O2 makes 2H2O.
All right. Let's dissect this a little bit.
Let's interpret it.
Here we go. The 2 in front of that H2 means that there are 2 moles of hydrogen, diatomic hydrogen molecules.
So there's 2 H2s.
Correct.
2 moles of H2.
Correct.
Okay.
But it also means, because of that
distributive property.
Right, that subscript behind the H, that there is 4 total moles of H atoms.
So the big the big coefficient out front applies to how many molecules or moles of molecules we're talking about.
Yes.
And you have to sometimes distribute it back into the problem in order to count the atoms. Okay, I got you.
Now,
Let's
it's
see
a
what else
little
we got.
nuanced detail, which is obviously important. Molecules and atoms are not exactly the same thing.
Molecules contain a number of atoms.
There we go.
And so this double distribution here gets to the root of the thing, is how many actual total H's did you have on the left side of this arrow? 4 moles of them.
Yeah.
Cool.
Got it. So all right, let's move on
I
to
see where
oxygen.
we're going with this. Cool. 1 mole of O2, which means 1 mole of diatomic oxygen molecules,
Correct.
gives me 2 total moles of O monatomic atoms. Because I'm distributing the 1 back into every subscript in the compound.
There we go.
Cool.
Okay, now water is our product.
H2O, yes.
So I have 2 moles of water.
Molecules.
Right. 2 moles of water molecules. Water itself is a molecule.
Okay.
So, you know.
Yeah.
But if I were to count H's just in the water,
Monatomic H's.
I would have 4 moles of hydrogen atoms within the 2 moles of water molecules.
Right, because the water molecule itself contains 2 hydrogens, and since we have 2 moles of water, it's 2 times 2 is 4.
There you go.
Okay.
And then we have to distribute that on top of the O now also.
Because that coefficient goes to everything behind it.
There we go. So now there's 2 moles of monatomic oxygen atoms.
Just before we move on, I get it, totally. Did you notice that we had 4 moles of monatomic hydrogen on the left?
Yes.
And 2 moles of monatomic oxygen on the left?
Uh-huh.
We have the same amount afterwards.
Ooh.
What did we do with all those atoms, Mr. Milks?
What we did was we rearranged them
to make molecules.
Right.
Or different molecules.
We learned conservation of matter.
Not yet.
We did in our vocab.
Oh yeah, our vocab. You can't create or destroy vocab.
Right.
You can't create
but we can rearrange them.
You can rearrange atoms. So we just rearranged atoms. We didn't lose any.
Yep.
We didn't create any.
Right.
This is called a balanced chemical equation, which you'll see again later.
Oh,
I always got to put my plugs in there.
It's all right. It's okay.
Okay.
It's good. Foreshadowing. We like that.
Foreshadowing.
We like that.
Literary elements in chemistry class.
Here we go.
What?
All right. So example number 2, counting moles of atoms and compounds. Let's use the whole rusting
Of a
iron.
bike chain. Yeah. This happens when you leave your brake pads out in the rain. You just had yours replaced.
Yeah,
You're rusted through.
Yeah, seriously.
So let me see here. If I'm going to count moles of atoms,
Let's start with the first one.
so this means 4 moles of iron. So 4 Fe's. So there's 4 Fe moles. So 4 moles of Fe. So 4 Fe atoms.
Right, and and notice it's not a compound, so
Right.
we're not going to call it a
Element.
molecule. It just is atoms.
4 Fe's. Sure.
Yep.
Got it.
Okay.
Write it down in your notes.
Right. I want to see this under there. Absolutely.
Mm-hmm.
Now this is where the rubber hits the road. If you're not writing what we're talking about here,
You're not getting a full color.
yeah, seriously. All right. So now the 3 in front of the oxygen. That means I have 3 moles of diatomic oxygen molecules.
So you have 3 moles of O2.
Correct.
So
I have
if you're
3
to count them
moles
all
of
up
O2.
individually, though,
Then I have to multiply,
3 times 2
and I'd have 6
moles of straight
oxygen atoms.
Oh,
yes.
Got it. Okay.
Okay, the difference between the atoms and the molecules.
Now we made in this rusting reaction 2 moles
Of
of
this iron
this
oxide.
compound, iron
Iron
3
3
oxide.
oxide.
Yeah,
Yeah.
Fe2O3. So I have 2 moles of Fe2O3, which means I have 2 times 2, 4 moles of Fe,
Correct.
and 2 times 3, 6 moles of just straight up O.
Correct.
Exactly what I had started with.
Beautiful.
So we rearranged them, made a new compound. It's called a chemical reaction.
It is.
Woo!
Right.
Can you find my typo, Mr. Mills?
I did.
Yeah.
Because this is going to be example number 3.
3 now.
There's a little carrot for you.
Yep.
Just kudos to anybody that crosses off that 2
Or,
and writes a 3 in there.
and kudos to anybody else who puts a little star on this one and says, Mr. Milks doesn't like combustion reactions in
Oh,
this unit.
never. I love combustion reactions.
Not in this unit, though.
Well, you know,
I get my plugs because I'm the MoNaCo, and this is a combustion reaction
this is. I know it's a combustion reaction. Why?
because you made H2O and CO2 produced on the right-hand side of that arrow,
Yep.
and you consumed or reacted, used up O2 on the left-hand side of the arrow. That's how I know any reaction is a combustion.
There you go. Now, I didn't animate this one at all.
No,
We're going to do this one
verbally.
verbally.
So you got to have a few notes,
And
bullets.
I got to tell you, Monica, we got a problem right here because every one of these other ones had a number in front of the compound. And now I got CH4 there and I got no number. So you tell me, how many of them do I have? How many
Well,
moles?
just like in mathematics class, if there's no number in front of X, it's assumed that it's 1.
Beautiful.
So in chemistry class, if there's no mole coefficient in front of your compound, you assume that it is a 1 hiding there. So this
Okay.
is 1 mole of CH4,
Which means
that there's 1 mole of carbon and 4 moles of H,
right of hydrogen
atoms in that first reactant CH1.
Okay, now in the second one, I see I have 2 moles, so that's 2 moles of O2. And if I distribute that out to get to atoms, I would be 2 times 2 would be 4 moles
of
oxygen
O
atoms.
atoms. Yeah.
Yep, okay, good.
And that's our reactant side taken care of. So our product side, again, we want to see a list of these atoms listed out for credit here. So you have CO2, no mole coefficient, so we assume it's 1. So there's 1 mole of carbon dioxide, CO2, which means there's 1 mole of carbon atoms and 2 moles of oxygen atoms in the first product here. But I notice there's oxygen in another place too.
There is, so it definitely broke apart.
Mm-hmm. So what's that last one, Mr. Milks? Take it
I
away.
see a 2 in front of H2O, which we do know is water. So I have 2 moles of H2O, is what the first 2 means. And if I want to get deeper into the constituents of water,
Let's get to the atoms. Yeah.
right, I would have to multiply the 2 after the H by the 2 in front to say 4 H atoms, 4 moles
of H
H
atoms.
atoms. And then the 2 times the 1 after the O would be 2 moles of oxygen atoms.
So if you're talking total oxygen atoms on the right-hand side, we have 4 moles of oxygen atoms,
Because we have 2 in carbon dioxide,
and 1 times 2 in H2O.
which is 2.
So we have,
4.
if you're counting up all the atoms and trying to keep in track, we have the same amount of each type before and after, so we're obeying the law of conservation of mass.
Foreshadowing.
More foreshadowing. So let's see what
That
else
was
we got.
mad eerie, mister.
Super spooky. So you got to know what the coefficients mean. you got to be able to distribute that coefficient after you've distributed your subscripts,
Right.
so you can find out the total number of atoms of each type in any compound that's written in a chemical equation,
There you go.
because it's going to matter.
I think the big picture here is the subscripts after a parentheses only deal with the parentheses and what's in it, and the
Mole
the
coefficient out in front
is for everything that follows that particular compound.
afterwards. Yeah, so you do your subscripts first, distribute those back through, and then take your atom totals and multiply by the
Sure.
mole coefficient out in front to truly get your genuine totals.
Sure.
Thanks for listening to us be wacky at this end of the day on a Tuesday in December.
Yeah.
Have a
With
good
no
one.
snow.
No snow.